Welcome to the next lecture in the BIM Basic series. Last time we talked about creating object-oriented BIM models, their multidimensionality and details. Today we will discuss basic BIM standards and processes, as well as data exchange formats with particular emphasis on the interoperability of Open BIM tools and philosophy. We will start with interoperability of BIM tools, the implementation of which is mainly an Open BIM approach. Then we will discuss data exchange standards and formats. They are described in the three main ISO standards. Subsequently, it will be a data description, the IFC format, a description of processes in IDM, definitions in IFD. I will also mention the BCF format, which is extension of the IFC for the cooperation of project teams. Finally, there will be a COBie non-graphical datasheets and BIM-compliant building classification. In the field of BIM information and management processes, we will discuss the most important BIM documents, such as information requirements, the roles of people in the BIM methodology, and a BIM execution plan with information delivery plans.
Let's start by discussing the interoperability of BIM tools. Over time, the development of BIM technology resulted in the creation of independent tools whose environment was related to the software producer. This did not allow one of the basic assumptions of the BIM methodology to be achieved, which is data exchange interoperability. No single computer program can handle all the tasks related to the design and construction of bridges or building structures. Interoperability means the need to transfer data between applications, allowing different team members working on a construction project to collaborate. In CAD techniques, interoperability was based on a simple file exchange format such as IGAs in the past or DXF. It means drawing exchange format established by Autodesk, which can only exchange geometry. I compiled the most popular formats used in the AEC industries in this table. I mean architecture, engineering, and construction. These are formats designed to save raster and vector images, describe surfaces and 3D shapes and solids, and exchange objects between applications. And there are GIS formats for recording terrain information, universal XML formats, and even formats used in the video games. In this picture, we really have only a selection of computer programs used in the AEC industry. And you can see how diverse they are. Each of these programs saves the model in its native format, which will not necessarily be readable by another program. Rarely, representatives of different industries cooperating in a project, and often even in the same industry, will use the same program as the same recording format. Therefore, when exchanging data and models, they must use export tools or some universal formats. The authors of publications on BIM usually look back in search of these disciplines' pedigree and the most important milestones in its development. The figure shows selected events on the timeline that influence the evolution of the BIM technique. One of the most important British measures to increase construction efficiency was the development of the British Standards Institution's necessary standards. In 2007, a series of BS 1192 standards was issued in Great Britain, which formulated general principles of information management in the construction industry, including the client's requirements for the flow of information in construction projects. I mean, employers' information requirements. Besides, the standard defined the requirements for a BIM implementation plan, that's the BIM execution plan, BAP, and defined the most important roles in BIM process. The BS 1192 standard has become the basis for the preparation of tenders for construction works and their implementation for many construction infrastructure owners. It is worth noting that the construction contract subject was the delivery of the physical object itself and the necessary information in the established standards, and ensuring the required information management method based on a common information environment, CDE. The publication of BS 1192 and a series of international ISO 19650 standards has significantly accelerated the implementation of ISO 55000 compliant asset management systems and information management systems by infrastructure managers. In the case of IT BIM models, the formats used in CAD and GIS techniques turned out to be insufficient. So software vendors began to communicate, and organizations such as Open BIM Network and the National Building Specifications and the Building Smart International were born. They contributed to positive changes, thanks to which new tools are becoming more and more useful for all users, not only for the industry for which the software is dedicated. In 1984, the Industry Alliance for Interoperability was established to develop an object-oriented class structure for storing a unified building model. The association was then renamed the Building Smart organization that exists to this day. It deals with developing the universal IFC standard, IFC data exchange format, which means industry foundation classes, and other related standards. It is mainly the Information Delivery Manual, IDM, describing what data and when are to be transferred in the business process, which can also be the construction process, and the Information Framework Dictionary, IFD, which describes the stored data in the form of a dictionary of terms. Together, they create a coherent concept of the so-called Open BIM, represented on such triangle. In short, it can be said that the IFC defines how to store data, IDM determines which of these data we intend to transmit and when, and IFD describes what data we store. Standardization and the system of standards and technical requirements is the basis for the functioning and development of all sectors of the economy. The construction industry also uses many such documents. Some of them regulate general requirements or relate to other types of industry that are related in some way to our industry, construction industry. There are also norms, standards, which with a much narrower application that correspond to the specificity of, for example, bridge structures, bridge construction. Introducing the BIM methodology to widespread use also requires appropriate standardization, which will ensure equal access to the services and supply market and freedom of competition. Currently, the most intensively developed international standards in BIM are the result of combination of works within the Building Smart Association and the ISO and SAN organizations. They are characterized primarily by opens to all producers of software tools for creating and editing BIM models. The condition is implementing the standard in a given program by creating appropriate commands and algorithms for data exchange. I mean, just export and import, which is not usually simple. And then certification of a given software version. In this way, the interoperability of programs and data can be ensured and cross-sector cooperation can be also ensured. It is also one of the most widely used Open BIM standards globally, an open and universal approach to the team design, implementation and maintenance of buildings. This approach also ensures the best compliance with the requirements and regulations of the public procurement market. Contrary to the so-called closed BIM or lonely BIM, in which designers, also from other industries, use the tools and data formats of one software producer. In addition to these three basic standards, IFC, IDM, and IFD, which are successfully implemented in other European countries, there are also many other standards, such as pre-norms, national and international standards. I've compiled some of them in this table. It shows that BIM is not some specific building modeling programs, but a comprehensive approach to construction processes. It simply aims to digitize and improve its governance. Here we have shown the transformation of British standards and pre-standards into the ISO organization standard system. Similar works are now underway at the Polish Committee of Standardization, and successive ISO standard related to BIM will be translated successfully from English to Polish. The basis of this triangle that accompanies us today is the IFC format, which means Industry Foundation Classes, used for modeling data about buildings. The IFC exchange format is described in ISO 16739 and is available on the Building Smart website. Although this standard is already marked in Poland as PN ISO, that's a Polish standard, it has not yet been translated into Polish. It describes the world's most widely used standard for digital 3D model recording, including information about a building object. It is the IFC format. It is an open international standard for BIM data used for information exchange between participants' software in the construction process. The description of the data schema was carried out using the Step Express language, which is used to describe the data structure and the relations between them. The IFC scheme was also supplemented with XML. Its syntax is based on tags that look like HTML structure used to create hypertext documents. The use of both data description methods makes it possible to present the object data in the form of open text. Thanks to this, it can be read and written by any software adapted to this. The IFC standard is created from scratch through extensive international and cross-industry consultations of the engineering community as part of the Building Smart organization. This is what a fragment of an IFC file looks like. As I said, this is an open ASCII text file. Each row has its identifier in the form of a row number. These files, individual fragments, are used to describe the geometry, properties, provide parameter values, number of elements, and classification. In this figure, we can see the most important classes included in the IFC4 version. This standard hierarchical structure is divided uh, into layers that are ranked from the most basic, which are at the bottom, to the most complex, which are on top. The core layer is the layer that connects the operation of the entire model. It uses the underlying resource layer to create the classes derived from interoperability and domain layer. The first is a set of general multidiscipline classes for construction, while the second contains discipline-specific elements like architecture or civil engineering. An essential class in the IFC class hierarchy is the IFC object class that describes everything that exists. It is quite a broad term taken from programming, which can mean physical objects like a beam or column, and non-physical objects like processes or resources. Also assigned to this class are dependency relations between objects such as association, allocation, aggregation. This diagram shows the IFT objects subclasses representing physical items, processes, events, resources, participants, projects, and groups in turn. From this diagram, I just choose an example of computer implementation of the IFC column class and saved it in the Express language. The line of this record, number 347, is at the bottom. The meaning of the following fields is explained in the table above. Here we can see a fragment of the structure of the IFC format classes and the location of the IFC column classes that are interesting to us. Well, because the IFC format is open and text, you can easily create tools for its generation, modification, and interpretation. Uh, there are also many free viewers for models saved in the IFC format. Here's just one example in the form of the now undeveloped Tekla BIM site software. After Tekla, Scandinavian Tekla was taken over by the American corporation Trimble, its role was taken by was taken over by a new Trimble Connect product. Polish BIM Vision browser, developed by the Krakow company Datacomp, has excellent reviews. These programs' advantages are the open IP that allows you to create plugins or use a graphic engine in your applications. In this way, the handled number of users expands, community panels, and new application areas. Here we have an example of the German product Salibri, and here the Trimble Connect, which is the successor of Tekla BIMsite. Still BIMsync, you can see that all these programs differ in terms of interface and functionality. Each of them has its supporters and critics, of course. Quite simple, IFC is just becoming an equivalent of PDF document viewers. Danish Dalux is developing its browser, which is dedicated to mobile devices such as tablets or smartphones. Finally, I wanted to show you the open source XBIM, which can work as an independent application, but you can also use its IP to engine to create your own applications operating on the IFC model. The Building Smart organization is gradually developing the IFC format. Uh, the implementation of these standard in the commercial applications appears with some delay, of course. The date of the standards announcement doesn't mean that software producers will be ready for implementation simultaneously. It can be seen, however, that until 2018, IFC only allowed to describe cubiture objects. Nowadays, it wasn't even possible to add georeferencing, which is the basis for describing any linear feature like bridge, road, or railway line. Bridge elements appeared only in the version of 4.2, but are only now implemented in commercial programs. In subsequent versions, elements of the railway and water infrastructure are to be added. The target version is to be IFC 5, which will contain all the most important construction objects like buildings, roads, ports, bridges, railways, airports, and energy facilities will be initially implemented. Here it is shown in a slightly different form from IFC 4.2 to IFC 5. You can see that consultations with the industry and software producers are postponed to the final stages and not end right after 2022. The processes are described in the norm in the standard, which is the right side of our triangle here. There is IDM called Information Delivery Manual. The IDM exchange standard is an information delivery instruction described in the two-part ISO 29481 standard. These standards also have a PN Polish equivalent, but still without translation. Its purpose is to define and locate the data that we want to transmit using IFC files. Usually, the number of participants in the construction process and the amount of information exchanged between them is too large to be directly implemented in the IFC record. Each participant only needs a specific and necessary part of all data. And this change along with the successive stages of the facility's life: design, construction, and maintenance. Also, as they move to the next stages of the project, including the facilities life cycle. They often change. To effectively describe these changes, a tool was created to describe business processes and related data exchange in a process map. IDM architecture is shown in this diagram. It shows the structure starting from the top of the typical business part, through the data specific part in the middle, to the bottom part, typically related to the software. On the sides, on both sides, there are information exchange requirements related to the business rules of the process, as well as software verification tests. In the first stage, a process map is created, and then, on its basis, information exchange requirements are formulated. It is a document that describes all the identified data. These could be, for example, drawings sent between engineers at the very beginning of the project. On their basis, computer implementation, that's the functional part, is created. Their task is to describe the repeating elements of the information exchange requirements in a programmable way. The process map describes the activities needed to exchange information in a given process. Thanks to it, we obtain a list of activities in the process, the sequence of activities, a list of process participants, and indication of the information exchanged. There are different methods for creating process maps. The business process modeling notation, BPMN, method was adopted in the IDM standard. It is a graphical notation used to describe business processes and models, often used to optimize enterprises' processes. This notation is developed by the independent organization OMG in its Object Management Group. Here we can see a graphical instruction on how to use BPMN to create a process map using this notation available on this organization's website. It has also been Polonized in Polish version for some time. Here we see selected symbols used to create process maps in magnification. So we have gates, activities, events, connections between events or activities, and choreographies and data types. In this figure, we see a straightforward example of a process map. These maps, main objects, are process implementation sites. These are horizontal tracks to distinguish actors and processes. We only have two actors here in this simple example, the project manager and project engineer. Next, we have activities that describe the tasks they perform. And we also have data objects that describe the information transferred between participants. These facilities are used for the preparation of information exchange requirements documents in specific places of the transmissions. They are marked in red here. The management of definitions and names is described in the form which is in the norm, which is the left side of our triangle. It's about IFD, Information Framework Dictionary. The IFD standard is described in the ISO 20006 standard. It facilitates the creation of multilingual dictionaries, terminologies, or ontologies. IFD provides a feasible method of linking IFC data to existing knowledge systems, projects, and product databases. Moreover, IFD provides the possibility of multilingual translation of information from IFC, introduces a conceptual grid, calling it ontology, used in the construction industry by the linguistic and legal localization of the terms used. Examples include fire resistance or door width. It has different names in different countries, like fire rating in English, and different description units, like Fahrenheit degrees or hours, depending on the country, on the standard. The IFD postulates to assign each concept of the unique global unique identifier. Here, an example of the door with parameter. IFD was used to create a technology labeled BSDD. That's the Building Smart Data Dictionary. It is a library of objects with the attributes which, thanks to special references, assigns descriptions downloaded from the database to elements present in the model. Thus, it enables the precise identification of the information contained in the model. The independent BCF format, called BIM collaboration format, is responsible for supporting cooperation. Collaboration and communication flows have been deliberately excluded from the scope of the IFC. IFC was intended to provide self-contained data models. However, it didn't solve the need of exchange information related to a specific part of the project, such as requests for information. It also didn't allow for the coordination of sequencing or solving problems occurring during project lifecycle. To guarantee a neutral way of exchanging questions, comments, and problems regarding IFC files, a neutral BCF format was created. Its history dates back to 2010, and at that time, Tekla and Solibri began to develop an initial BCF scheme called BCF XML. Here we see an example of an application with an interface for exchanging information, inquiries, comments, and submitting comments on the model. In this way, we can define the place on the model to which we want to comment. This could be information that there is a collision, that there is a bug, or that it needs further investigation. Now a few words on a non-graphical COBie datasheet. This format is not so popular in Poland yet, but it is also an open format, and it fits in it with the Open BIM philosophy. COBie is a documentation standard that contains data for facility management. It is in the form of a simple spreadsheet. It is completed depending on the project phase. The sheet data includes the equipment of the facility and information about each of the equipment elements, technical and operational parameters, origin, price, warranty period, date of installation, spare parts lists, inspection dates, etc. It can be used with various building classification standards, which I will talk about in a moment. For example, the American Omni class, or the British Uni class, or the Norwegian NS 34551. The most important feature of the COBie is interoperability, which is both at the user level because the data recorded in this standard is available and understandable for virtually every supplier and other participants in the investment process, but also interoperability at the designer level, because many programs used to create 3D models have the option of automatic COBie file generation. Openness is also important. COBie is fully compliant with the IFC open format and multidiscipline because it covers all industries in a given building structure. By saving them into the COBie sheet, they can then be easily imported into facility management systems. Here we see an example of the COBie plugin used in the IFC file viewer. Selecting objects on the model highlights certain lines objects of the sheet and vice versa. Selecting the sheet rows results in highlighting the object in the model. Now we will discuss the construction classification, which should also comply with the BIM methodology. Apart from the norm standards discussed earlier, construction classification systems are also important. This is about the classification of materials and types of works used in construction, like the Polish classification of products and the services known in our country. Besides, there are also such systems in Poland as Polish classification of construction objects, Polish classification of activities, common procurement vocabulary used in public procurement, or used in the costing of material input catalog. I used these yellowed books myself when I was still a student in the times of communism in Poland. It was many years ago. Unfortunately, the approach to costing construction works in Poland has not changed since then, and it's time to finally change it with the implementation of the BIM methodology, because virtually none of these classifications can be directly implemented in BIM compliant tools or even CAD. Meanwhile, there have been construction classification globally for a long time, which were first used in CAD systems and then developed and adopted to the BIM methodology. The most famous systems are the American OmniClass and the British UniClass. The OmniClass system is a classification system used to organize and retrieve information in the construction industry, developed by the US Construction Specifications Institute in the early 1990s. Today complies with the latest international ISO standards for BIM. OmniClass contains 15 tables, which also includes products and works. Each table can be used independently to classify a specific type of information. They cover the entire life cycle of the facility, from the concept to its demolition. The system is widely used by ordering parties, by clients, designers, contractors, and administration to complete data in BIM models and even inspections and technical condition assessment. Here's an example of using OmniClass to describe several products and works. So we have the activity of designing bridge structures with long spans, which probably requires different outlays than in the case of short spans. This example shows that design services can also be priced in this system, with works involving bolting constructions and even services in the form of inspections during the use phase, operation phase. For the product description, I choose bridge bearings and prefabricated hammered piles. UniClass is a consistent classification for all products in the construction industry developed by the National Building Specification in Great Britain. It contains tables that classify items of any scale, from small products, like an elastomer bearing, for example, to large objects like bridges or buildings. Uniclass complies with the ISO 19650 series series of standards. It is divided into 12 tables that categorize information used for costing, delivery, specification, CAD layer naming, etc. The table layout is hierarchical and allows you to find the information you want easily. NBS has also prepared a convenient platform for assessing the classification, which is based on cloud solutions. Here in turn is an example of using Uniclass to describe several products and construction works. So we have fixed bridges, bridge abutment wing, bridge bearing, and even an elastomer expansion tape for expansion joints. I just choose the formwork assembly and the bridge inspection for works. For the effective implementation of the BIM methodology in our country, any country, there is no Polish construction classification system that could be used for costs with the use of BIM models. Such a system should be compliant with the provisions of the Polish standard PN ISO 12006, which will ensure its consistency with international standards. It will also be desirable to use good European examples, but of course taking into account the specificity of national costing practices. Now let's move on to the rather monotonous and boring description of BIM information and management processes. Unfortunately, we have to go through it because, in fact, it is a key element of the BIM methodology. When performing contracts using the BIM methodology, several additional documents and procedures are used in relation to the classic contract provisions. They result from the relevant standard regulations, in which the ISO 19650 series of standards is the leading one. These standards were created based on the British standards of the base BS 1192 series, which had previously been tested in practice on many contracts. They transfer to the international level resulted from their effectiveness in implementing BIM in Great Britain. It also made more and more countries decide to implement the BIM methodology in this way. Each of the additional contract documents related to BIM has its own defined English names and corresponding abbreviations, which have already become popular in the BIM expert community. Unfortunately, they have not yet been translated into Polish and therefore do not have Polish abbreviations. These include, first of all, EIR, BEP, MIDP, CDE. On the occasion of the preparations for the first pilot project in Poland in the infrastructure, the consultant team selected by National Road Administration in the form of ECC BIM Foundation developed a dictionary of the most important terms related to BIM. This dictionary was later developed into the BIM standard PL, thanks to which it can be consistent with the future national regulations. The BIM approach presented in the ISO 19650 series of standards is a step forward from the previously described BIM maturity stages, which I showed you in our second lecture. The key is the general diagram taken from the standard that you can see on this slide. Uh, it shows the process of communicating, the using information about the investment and the building object, which already includes an approach based on the building's whole life, starting from design, implementation, and operation. The method of information management and data processing depends on all construction process participants like client, designer, contractor, manager, who take responsibility for the part of the entire process. This means that investors who ask for a, let's say, BIM project in the contract will not meet the requirements of ISO 19650 and will not achieve the expected benefits. Their participation in accurately determining what they require is of fundamental importance. The same will be true when inappropriate tools are used in the BIM process. For example, using a shared plane cloud drive as a CDE solution will not meet ISO requirements. The client's precise information requirements and goals that he wants to achieve concerning BIM use are also related to the investment lifecycle. This is because the information model of a building is created differently at the design stage and differently for the operation and management of the finished object. The first case is referred to as the Project Information Model, PIM, which designers in the design process produce when not all of the details of the BIM model components are needed. The manufacturers and suppliers on specific solutions and equipment are not yet known. It is enough for the required target parameters to be defined for them so that it is possible to prepare project documentation. Based on such a prepared PIM model, and the contractor and subcontractors already create the operational asset information models, AIM, already in the implementation process. Before the final commissioning, the information of the BIM components used is completed. These can be exact performance parameters, service information, warranty periods, datasheets, certificates, and material tests, load tests of the bridges, etc. These documents and information may be associated with 3D graphical objects. Still, the IAM model, due to the nature of the data stored, often has in the form of a spreadsheet, as is the case with the COBie standard described below. Therefore, the ISO series standards are a guide on how to manage the information process to obtain the greatest benefits from the use of the BIM methodology in the investment project. From the very beginning, by specifying the PIM model's requirements, but also after completion of construction by entering the requirements into the AM model. The implementation of the BIM information process of maturity level 2 follows the principles described by ISO 19650 standard. The first principle is the purpose of the information process uh, to create an information model for a building's design or operation. These models are to be structural repositories of information needed to make decisions in the facility's lifecycle, in the design, construction, reconstruction, operation, and demolition stages. Models can contain structured information, which is of course preferred, or unstructured, like an example in the form of visualizations or video clips. The second principle is the BIM information process carried out in an environment in which individual process actors' responsibilities are right and clearly defined, most often included in a table called the responsibility matrix. There are also control and management functions closely related to the BIM process. It gives, among others, a BIM coordinator and manager or information manager. The third principle, the contracting party referred to in the ISO standard as the appointing part, the client, and the site of the main contractor and its subcontractors, as well as other project stakeholder parties work together in one environment to produce the desired PIM or AM information models. Fourth principle, the parties' rights and obligations related to the information process result from the formally concluded contract or supplementary annexes. In the ISO standard, they are called information protocol. The fifth principle, the process is divided into stages. In contrast to the British BS 1192 series standards, the ISO 19650 standard allows the project to be divided into any number of stages according to the client's needs and the project specificity. The stages are related to project milestones and data exchange points. These are either specific dates or other specific time points. In example, depending on controlled or uncontrolled breakthrough events, such as obtaining an administrative decision. In these points, the employer requests information to decide whether to accept the stage or the need to further works. A sixth principle, at each stage for individual components of BIM models or groups, therefore, uh, an increasing level of the necessary LOD information is defined, which the employer requires to meet the stage's information needs. As a result of the project implementation, the project's information level and value are gradually increasing. And seventh principle, that all information exchanges take place through the centralized IT environment of the CDE. That means Common Data Platform, Common Data Environment. Everything is recorded according to established information exchange protocols. They include, among other, data exchange formats and versions. Importantly, the use of CDE is mandatory in maturity level 2 BIM projects. The description of the information process is contractually divided into 6 stages of the facility's lifecycle. These are the following stages: requirements engineering, strategy and guidelines, only in a brief, concept, scheme design and detail design, construction and commission, and finally handover and closeout. One of the employer's first tasks needed to define the process of managing development and delivery of BIM information models is to define the stages of the development of your own project. It is essential element of managing the BIM information process in the project, as these stages will be associated with many elements of this process, such as milestones of the project, scopes of information supply like MPDD tables, LOD definition levels, data delivery points, and deployers' decision points. They all constitute important components of the management process, as it were span the entire BIM process over time and link the development of information models in a qualitatively controlled project environment with it. These dependencies are shown in a diagram taken from the ISO 19650 standard. It isn't straightforward, but unfortunately, this is how construction process look like. The information process takes place inside the CDE environment. Management processes are represented by blue arrows around the CDE platform that surround the internal processes. According to the ISO standard, the BIM information process requires in turn determining information requirements, then planning the method and schedule of information delivery, our next stages of project development in green rectangles, provide information at data drop points uh, that are green circles symbolize these, verifying compliance of information with project's requirements at the appropriate decision points that are red diamonds, and finally approving information when requirements are met or rejected and sent for further works when they are not met. We are now beginning to review the most important documents related to BIM management process. The first is AR. The process of effective use of BIM and a contract begins with the definition of information requirements and the contracting authorities contract with service providers and individual stages of the facility's life. It could be different in the design, construction, and operation phases. In the first step, the contracting authority, the client, the employer, must define the scope and method of information management in the planned project or contract. The investor's requirements describing the ordered object and the context of its technical and functional properties are usually described in documents called the terms of reference, specification of essential terms of the contract, PFU, that's in Polish, it's Functional and Utility Program, or OPZ, this is also the abbreviation coming from Polish, description of the subject of the contract. Such a document in the ISO 19650 standard is EIR, meaning Exchange Information Requirement. It should also be noted that the abbreviation EIR and the nomenclature of British standards mean Employer Information Requirement, so it's a little bit different. In the ISO 19650 standard, the provisions concerning information requirements have been developed. It is about precisely describing the requirements for information processes that will be attached to other documents such as PFU or OPZ, already mentioned before on the previous slide. Already at the tender stage, the requirements in this respect should be specified for all investment participants. It is about the ordering party, designer, and contractor. Depending on the needs, they can cover both and all and selected stages of the project implementation, concept, design, construction, use. Well-prepared and all as precise information requirements as possible are a key factor enabling the joint and effective management of information during the project lifetime. The lack of clearly defined information requirements may increase the likelihood that the design of or contractor teams involved will not provide complete and correct information to support the decision-making process and progress effectively. Essential documents that the contracting authority should prepare for contractors and suppliers, those are Organization Information Requirements, OIR, which relate to the contracting authorities' own business goals, project information requirements, PIR, which relate to the goals and the implemented project, asset information requirements, AIR, which concern information about resources provided in connection with their subsequent operation and maintenance, EIR, exchange information requirements, which describe how the information will be exchanged between the parties. The relationship between these documents is illustrated in this diagram. You can also find the PIM and IAM information models described earlier, which are the results of the processes described in AR and EIR respectively. Besides, paths along which cooperation between the parties involved in investment can take place are visible. Therefore, three options can be distinguished. The first is to provide a project without considering asset management needs. Then in the second, provide resource or asset management information without considering project aspects. And finally, the third option, providing related project and asset information. And this is what the next points of the EIR document template looks like. So we have 5 chapters, and now we will trace their content. In the first one, we provide general information about the project, such as the name of the project and the client. Definitions with a dictionary of terms and abbreviations will also appear here. The second chapter describes the purpose of using the BIM methodology by the employer in the project. Knowing these goals, the contractor will easier understand the employer's intentions and thus will meet the employer's expectations more effectively. He will also be able to suggest specific ways to achieve the chosen goals. The client goals can be divided into 2 groups. Strategic goals, also known as the benefits of BIM implementation. This can be an example, better estimation of investment costs, lower costs, fewer errors, better quality, etc. And we have project goals, also known as BIM activators or BIM use cases. Their use is a way to achieve strategic goals. Examples of activators are, for example, for the strategic goals, lower cost. It may be the reduction of the number of collisions thanks to the automatic analysis of the 3D model, or more accurate takeoffs, allowing for more precise planning of purchases and deliveries. In turn, using 3D model and the schedules will serve to optimize the construction process. In practice, the employer uses the objectives of the project to select the contractor and then defines 2 groups of objectives in the EIR document. Mandatory goals that he wants to achieve by implementing this project, and optional goals, what he would like to achieve, but their implementation may be conditioned by the contractor's skills or available tools on the market. Optional objectives can be used in bidding processes as non-price criteria for evaluating bids. Measurable goals should be indicated. The so-called key performance indicators, KPI, they are financial and non-financial measures of the achievement goals. The third chapter describes the management requirements. The contracting authority provides the contractor with a template of another document, such as the BEP and the MIDP or MPDP tables. We'll discuss them in a moment. In this chapter, the contracting authority defines which norms and standards are to be applied. Next, the employer describes the file naming standard expected by him in the project. The file naming standard facilitates easier and faster access to information by all project participants. The file name can define the type of documentation, its status, and the area of the project it relates to. The next element concerns the role of people in BIM methodology. Now we will know them. The procuring authority, the client, should define expectations regarding roles and responsibilities in the information process. In response to these expectations, the contractor should assign specific persons in, and their contacts details to individual roles and responsibilities. BIM methodology and related information processes force the necessity to define new roles and responsibilities for the key personnel who implement the construction investment. These people's competencies and the experience required for them do not coincide with the requirements imposed on people currently performing the so-called independent technical functions in construction, uh, designer, construction man, site manager, or supervisor. Besides, they must be available to virtually all parties involved in the investment. Their knowledge and competences cannot be limited to only one architectural construction facility or geodetic industry. However, they must demonstrate a high level of skills in the field of digital information processing. Examples of roles include project information manager, BIM manager, BIM coordinator, or BIM modeler. Here we have an information manager that should be established on the client side. He creates and maintains the CDE environment, defines the information structure of the information model. He reconciles the output formats and checks for compliance, provides information obligations, determines the levels of detail at each stage of the project, coordinates information through the lead designer. He also helps project teams create information exchange process. The second key person is the BIM coordinator. He acts on the side of the contractor, develops BIM protocols and BEP plans, ensures adherence to these protocols, manages data sets, ensures the accuracy of models and data through quality process procedures, detects and avoids collisions, prepares BIM coordination programs and progress reports. Uh, he provides training and assistance to the project team, coordinates modeling and data management. I've also chosen a BIM manager who can be both on the ordering and contractor parties. He implements BIM in the organization, supervises the BIM process in the organization and the implemented project. He works with the information manager and the BIM coordinator. He can also act as an information manager or BIM coordinator. In the Contracting authority, in case of employer, he is responsible for defining the AIR, PIR, or EIR information requirements. In the case of the contractor, he is responsible for the preparation of BEP. Other BIM roles and positions include BIM modeler, BIM librarian, BIM data analyst, etc. Now we continue the EIR document. Next we have chapter 3, and more precisely work planning and data systematization. The contracting authority may impose the method of dividing the project into smaller parts related to design or technology, or the implementation methods, buildings, floors, areas, sections of works. This makes it easier to manage data and project documentation. The contracting authority defines the methods and tools that should be used to manage processes and data in the project. The primary management tool should be the CDE platform. Therefore, the contracting authority specifies the expected scope of its application in the project. Data security requirements and the method of authorizing, authorizing access to the CDE platform are also specified. One of the basic goals of using 3D BIM modeling is to detect and eliminate design conflicts at the earliest possible stages of the project, which significantly affects investment's implementation costs. Due to the importance of coordination and detection of collisions for the employer, EIR introduces detailed guidelines regarding collisions type and scope, which should be verified at the design stage. The processes that the contractors should carry out to eliminate collisions are also described. The most frequently analyzed collisions are intra-industry and inter-industry geometric design collisions or with the existing and planned infrastructure. That could be code design collisions resulting from a violation of standard conditions. An example regarding the permissible minimum distances between installations of various types facilities, as well as assembly and operational collisions. The employer then defines its expectations regarding the model review meeting. They are quite precisely described, and the dates of meetings are most often associated with the schedule of data delivery points, data drops. The contracting authority may also define its requirements for using the BIM models in health and safety management. These requirements may apply to the design stage, includes design taking into account health and safety aspects, such as safe access zones, equipment collisions, making danger zones, security design, etc. It can be the implementation stage. In example, designing the staging of works phases for safety related to the saturation with the equipment or people of specific areas, daily briefings using the model and indication of potentially dangerous zones, simulations of equipment operation, coordination of work and delivery logistics, etc. And finally, and the operation stage, an example, safety of facility users, renovation teams, evacuation routes, monitoring, alarm signaling, etc. The contracting authority should also describe the requirements and the fulfillment of which will guarantee the integrity of the BIM project's models and documentation, the compliance with the quality requirements, and the control of and verification tools. The employer should indicate its requirements regarding the method and scope of providing information about the finished facilities and its assets. It is necessary for the maintenance and operation of the facility. The employer plans to use the scope and types of data and the facility operation stage are described here. Since the BIM methodology requires appropriate standardization of data and processes, a critical element of the BIM process is to define a software ecosystem for the project and that guarantees the best possible exchange of information between all project participants. In the fourth chapter, the contracting authority, the employer, defines its programming requirements that will be used by the contractor in the project, especially in terms of file compatibility. In example, the compliance of the version number of the software used by all project participants. The requirements for the file formats acceptable in the project are defined. Most often, it results from the software owned by the client. One of the basic elements influencing the effective coordination of design models is the definition and use of a uniform coordinate system, and in the case of using local coordinate systems for various models, ensuring an ambiguous spatial transformation to the plane coordinate system and the geodetic elevation system. In the next part of the fourth chapter, the levels of detail of the model are defined. Here's an example modeling level table for some sample industries without breaking down into components groups. Since an effectively conducted design or construction process based on the BIM methodology requires appropriate technical competencies, it is a common practice to expect the employer to prepare a competency matrix specifying the necessary level of skills and knowledge regarding BIM processes and tools for the key employees of the contractor and the employer. One of the basic elements of the BIM process is transferring the generated and accurate data to project participants. From the employer's point of view, it must obtain certain data from the contractor. These data can take various forms: text files, tables, lists, drawings, like CAD files, models. Contrary to the traditional process, a BIM-based process defines many more data delivery points, calling data drops. Their purpose is to obtain the information necessary to make certain decisions, check the correctness of the proposed solutions, check whether the BIM project documentation is implemented at the specific level of detail, approve the stage of work, launch administrative procedure, etc. Here we see an exemplary schedule of key data delivery points for BIM model analysis. The ISO 19650 standard recommends breaking down the supply of design information. It's a PIM model, according to project phases or stages, and in the case of information related to design maintenance, that's a AIM model, breaking it into packages related to anticipated maintenance events. The contracting authority, the employer, also specifies the scope of BIM documentation and its requirements. BIM documentation may include industry models, coordination models, isolated models containing specific data, 4D, 5D, or 6D, mapping the tables associated with models, CAD drawings, 3D CAD models, simulations, animations, visualizations, results and analysis reports, clash reports, uh, reconciliation and communication reports, etc. Here we can see typical requirements for models such as data saturation and recording formats, access from the BIM model level to properly described BIM documentation, the ability to generate coordination model, etc. The employer party may suggest or impose the use of specific method of model division, taking into account various criteria. An example, model size, global division, the function of object elements, construction technology, geometry, sections of various contractors, or the planned scope of model use. If the ordering party has specific industry models requirements, it should describe them here separately for each of these models. The ordering party may describe its requirements and expected BIM competencies regarding both the contractor's organization and the individual key participants in the BIM process on the contractor's side. The description is intended to indicate to the potential contractor of the areas of competencies that, according to the employer, will be necessary during the project implementation and the requirements that the contractor may meet. So much for the chapters of the EIR document. Now we will briefly deal with the BEP document. Um, that's the Performance and Information Delivery Plan. In response to the information and information exchange requirements described by the contracting authority by the employer in the EIR document, the contractor must prepare its own implementation plans for these demands. Document templates with defined names and standardized structure are used for these. They mainly include the BIM execution plan, BEP in shortcut, and the main and task-based project information delivery plan, in short, in abbreviations MIDP, that's the Master Information Delivery Plan, and TIDP, Task Information Delivery Plan. This is what the next points of the EIR, of the BEP template according to BIM Standard PL look like. So we have 8 essential points preceded by an index of abbreviations and expressions. We start with the general concept of how the contractor plans to use BIM in the implementation of the project. It should specify the planned scope of modeling that's distinguished between individual industries and the use of BIM in traditional design and construction processes such as takeoffs and inventories, creating documentation, material lists, costing and scheduling, use of documentation on the construction site, post-completion documentation as built. At this point, the contractor should provide tables of BIM goals and benefits for the project. It is permissible to divide the goals into strategic, obligatory, and additional goals in which the contractor will try to use BIM but doesn't guarantee the final results. Further, the contractor should present a general concept of creating, managing, and using project information based on 3D BIM models and the design, construction, and operation information. Here's the necessary to list. Here it is necessary to list and briefly describe the individual stages of the project implementation, giving key dates of commencement and completion of works and person responsible uh, for the correct and timely execution of the works. The contractor should define the schedule of data delivery points. Therefore, it provides their quantity and type as well as the scope of data exchange at individual points. Data delivery points, data drops, assume a gradual delivery of the produced documentation and allow for early detection of potential problems, both substantive, technical, or organizational. The contractor should outline the software's architecture, including key system solutions and the main data flow routes. This is where the CDE platform and its use in the project should be presented here. The contractor should present the standards and the procedures that will be implemented to ensure high quality and uniformity of BIM models and processes, CAD documentation, geodetic models, and GIS data. It also describes the adopted levels of detail of the model geometry and information entered into the model. Further, the contractor should describe internal verification and quality control processes. Both content-related and technical control of the produced documentation should be taken into account. We are slowly coming to an end. Uh, at this point, the contractor should present how he will ensure the security on the project. And in the last point of the BAP document, the contractor should present how he plans to ensure the project staff's appropriate competence. Employees and subcontractors should complete the attached responsibility table, and the contractor should provide a training plan and active support for them. And this is where they finish discussing the most important documents of the BIM process.
This ends today's lecture. We started with the interoperability of BIM tools, which is mainly implemented by an Open BIM approach. Then we discussed the data exchange formats and standards described in the three ISO standards. It was therefore the IFC format, a description of processes in IDM, definitions in IFD. I also mentioned the BCF format and COBie non-graphical datasheets. The BIM building classifications. In terms of BIM information and management processes, we discussed the most important BIM documents, such as information requirements, roles in the BIM methodology and BIM processes, and BIM execution plans with information delivery plans. Thank you very much for your attention, and I invite you to the next lectures in the BIM Basic series.